Hello everyone, I am Dr. Varalakshmi, Assistant Professor of Mathematics, Vardhaman College of Engineering. In this video, I would like to explain about F-test for equality of population variances in small sample tests. Now let us see the procedure of F-test for equality of population variances. So as in the earlier videos, we already observed that small sample test, if the sample size, the value of n less than 30, then we conclude it is a small sample test. In the small sample test, we observed that t-test for single mean, t-test for two mean, as well as chi-square test for goodness of fit and F-test. So in this F-test, we are going to check whether there is any differentiation between the equality of population variances or not. So now let us see here, if the sample size n less than 30, it has been drawn from the normal population. This is what we are going to check. So now, whenever we are going to check the equality of population variances, we would like to verify, as usual, we are having the 5 steps process. The first step is the null hypothesis. So null hypothesis means the statement of no difference is called null hypothesis and it is denoted by H naught. Now the thing is, we are going to verify that there is no significant difference between the two population variances. So that is what we are defining it as H naught is equals to sigma 1 square is equals to sigma 2 square. Now the second step is an alternative hypothesis. Alternative hypothesis means the statement against the null hypothesis is called an alternative hypothesis. So we are going to define it as H1 is equals to sigma 1 square is not equals to sigma 2 square. So here, as we studied in the earlier cases, whenever we are having two tile test, right tile test and left tile test. So whether the problem it is based upon the given problem, we are going to define about the type of an alternative hypothesis. And the third step is the level of significance. The level of significance we are going to choose it is either 5% or 1%. So as earlier cases, so if they won't mention anything in the given problem, we have to choose a fixed value. That fixed value is at 5% level of significance. If they mention anything, we have to check at 1% level of significance. Now let us see, the fourth step is the test statistic. So here, before going to the test statistic of f, we are going to finding out the value of s1 square. So that is what s1 square is equals to 1 by n1 minus 1 into summation of xi minus x bar whole square. And we are going to finding out the value of s2 square is equals to 1 by n2 minus 1 summation of yi minus y bar whole square. So now the thing is, we are going to finding out the value of test statistic f, that is equals to what? F is equals to s1 square by s2 square. Here the formula of test statistic of f is equals to s1 square by s2 square. We are going to write the numerator value, it should be greater than. It means that the value of s1 square is greater than s2 square. Then we are going to write this is our test statistic. In this case, we are going to define it as, obviously we are having the two samples of sizes n1 and n2. That is what we are going to define it as xi observations or from I from 1 to n1. So n1 minus 1. So here we are going to define it as yj is n2 observations. So it means that we are having two sample of sizes. So now we are going to define it as, we are writing only f is equals to s1 square by s2 square. That is only if the value of s1 square it should be greater than. So now in this case it follows the degrees of freedom as n1 minus 1 comma n2 minus 1 degrees of freedom. So a degrees of freedom means this is what we are going to set up to make a conclusion, that is the number of independent variates which make up the statistics. Now in the case, suppose we are having other case, if s2 square is greater than s1 square. In this case, we are going to write the test statistic is f is equals to s2 square by s1 square. This follows the degrees of freedom of, here in the numerator we are writing s2 square. So it follows the degrees of freedom as n2 minus 1 comma n1 minus 1 degrees of freedom. Now the fifth step as we are going to make it as a conclusion. So the conclusion as we are going to finding out, so based upon the calculated value of f, it means that the calculated value of f is less than the tabulated value of f, we have to accept our h naught. So accepting h naught means, so what we are going to make an assumption of h naught, there is no significant difference between the two population variances. So we are accepting that there is no significant difference between the two population variances. If any case, as we are having the calculated value of f is greater than the tabulated value of f, we have to reject h naught. So in case when we reject h naught in any given problem means, it means that we are going to conclude that there is a significant difference in the given data. So in this way we are going to conclude the procedure of F test for equality of population variances. Now let us see the problem on F test for equality of population variances. In one sample of 8 observations from a normal population, the sum of the squares of the deviations of the sample values from the sample mean is 84.4, and in another sample of 10 observations it was 102.6. Then test at 5% level whether the populations have the same variances. So whenever the given problem we are having the question of variances, we are going to check that it is the population variances problem and it is of a small sample test. So now as in the given problem we are having in one sample of 8 observations, let us see the given data first. As given n1 is equals to 8 observations, and they mentioned here that the sum of the squares of the deviations, it means that they are going to define it as summation of xi minus x bar whole square, that it is equals to 84.4. This is about a given value in the problem, and the value of n2 is equals to another sample of 10 observations, so it is of n2 is equals to 10, and we are going to define it as the sum of the squares of the deviations from the mean. They are going to define it as summation of yi minus y bar whole square. This is equals to 102.6. These are about the given values. Now we are going to make a 5-step process. The 5-step process, the first step is of what? Null hypothesis. So the given problem they are asking to define about that, to test whether there is any differentiation between the two population variances. So now we are going to define it about null hypothesis. H naught is equals to sigma 1 square equals to sigma 2 square. So the meaning of this is there is no differentiation in the equality of two population variances, or we are going to define it as there is no significant difference between the two population variances. Now let us see the next second step is an alternative hypothesis. And in the given problem, as they won't give you that in future it is going to increase or decrease, so they are asking only to define, to check whether there is any significant difference in the two population variances. So now we are going to define about H1 is sigma 1 square is not equals to sigma 2 square. So no need to write about the type of the test because we are going to follow only of F test. So you are not having any clarification of that two tile or right tile or left tile. Now the third step is the level of significance. Now in the given problem, they clearly mentioned to test at 5% level of significance. So we are going to define the level of significance is at 5% level of significance. Now let us see the fourth step is the test statistic. So here the test statistic is, before going to write the value of f, we are going to finding out which is more variance in the given problem. So the more variance we are going to finding out first, as we are writing s1 square is equals to 1 by n1 minus 1 into summation of xi minus x bar whole square. This is what we are going to define about. So now the thing is we are going to finding out the first sample of size observations 8 minus 1, so 1 by 7, the value of 84.4. We are going to define about s1 square. This is what? 12.05. And we are going to define about the second step as s2 square. Now let us see s2 square, the formula is equals to 1 by n2 minus 1 into summation of yi minus y bar whole square. So now we are having the number of second sample of observations is 10 in the given problem. So we are going to define it as 10 minus 1 is 9 and summation yi minus y bar whole square is 102.6. So we are going to define this is equals to, while simplifying this we will get it as 11.4. While observing this s1 square and s2 square, the value of s1 square is a greater value. So we are going to write a greater value in the numerator. So that is equals to what? F is equals to s1 square by s2 square. It follows the degrees of freedom of n1 minus 1 comma n2 minus 1 degrees of freedom. So now let us see here f is equals to, we are going to define it as 12.05 by 11.4. The calculated value of f we will get it as 1.05. Now the thing is we are going to finding out the table value. we got the calculated value of f here is 1.05 and the table value of f, we are going to finding out n1 minus 1, 8 minus 1 is 7 observations and 10 minus 1 is 9 degrees of freedom. So we have to check our table value of 7, 9 degrees of freedom at 5% level of significance. Now let us see how to verify the table value. This is F test table value at 5% level of significance. We are going to finding out the greater variance on the upper part of the table, and left hand side of the, we are going to follow the denominator table. So now let us see here. We are going to finding out at 7, 9 df. 7, 9 df. So the greater part is, you are going to define it as a 7 and the left hand side is 9. So we are going to verify this is 3.29 is our table value. 3.7, 9. So this is of our value 3.29. This is the tabulated value of 7, 9. So as per our table, we are going to define it as table value is 3.29. Now we are going to define about our calculated f is 1.05 and here the table value is 3.29. So the value, it should be a less than value. We are going to conclude that now this calculated value of f is less than the tabulated value of f. So as per our procedure, we are going to define whenever we are having the calculated value of f is less than the table weighted value of f, we accept our H0. It means that we are going to conclude that there is no significant difference between the two types of population variances. Now let us see one more problem on F test for equality of population variances. Let us see the problem. The nicotine contents in milligrams in 2 samples of tobacco were found to be as follows. In the given problem, they gave you 2 sample sizes. So here the condition is the sample sizes may be equal or may not be equal. Whatever it may be, they are asking about to check that is these 2 samples came from the normal population, or we are going to finding out whether there is any equality of these population variances. The test, it will be an F test. So now in the given problem, we are having the sample size of n1 and n2 is both or not equal. So n1 is equals to 5 observations in the given problem and n2 is equals to 6 observations in the problem. So we are going to finding out and identify the problem first. It is of both the samples are of the size is less than 30. So it is a small sample test and we are going to check whether these 2 samples came from the same normal population. We are going to finding about whether there is any significant difference between these 2 population variances. So for now these 2 population variances, we are going to finding out our first step is about null hypothesis. That is H0 is equals to, first we are assuming that sigma 1 square is equals to sigma 2 square. It means that there is no significant difference between the 2 types of population variances, or we are going to conclude that these 2 samples have came from the same normal population. So now alternative hypothesis means here the statement against the null hypothesis is called an alternative hypothesis. It is denoted by H1. We are going to define it as H1 is sigma 1 square not equals to sigma 2 square. It means that the 2 samples does not came from the same normal population. Now, in the given problem, they didn't ask to find the level of significance is at 5% or 1%. So we are going to take it as the standard level of significance is at 5% level of significance. And then we are going to, for the fourth step is a test statistic. So let us see here, before going to the fourth step of test statistic of F, we are going to finding out the first S1 square value and S2 square value. So which is more, that is what we are going to finding out first. So S1 square is equals to 1 by n1 minus 1 into summation of xi minus x bar whole square. And we are going to finding out S2 square is 1 by n2 minus 1 into summation of yj minus y bar whole square. So by using these formulas, we are going to finding about the value of S1 square and S2 square. So now as per our last table, we are going to finding out the tabular form of x values, and we are going to finding out x minus x bar and y minus y bar whole square. These values we are going to finding out to find the values of S1 square and S2 square. So now let us see, before going to finding out the second column, we are going to finding out first x bar value, that is x bar is equals to summation x by n. The sum of all these observations is 123 and the number of observations here is 5. So we are going to finding out x bar is equals to 24.6. We are going to finding out x minus x bar now. 24 minus 24.6, this is the value of 0.6. So 0.6 whole square, so 0.36. So now let us see here, 27 minus 24.6 is a value of 2.4. So now we are going to finding out 2.4 whole square is 5.76. And then 26 minus 24.6 is a value of 1.4, is a value of 1.96 is x minus x bar whole square. Now 21 minus 24.6 is a value of 3.6. We are going to finding out 3.6 whole square is 12.96. Now let us see here, 25 minus 24.6 is a value of 0.4. So 0.4 is 0.16. So now the thing is, we are going to finding out the value of summation of xi minus x bar whole square. So the value of finding sum of xi minus x bar whole square is a value of 21.2. Now the thing is, we are going to finding out the value of y minus y bar. We find out y bar is equals to summation y by n, the sum of all observations by the number of observations. So first thing, we are going to finding out the sum of all y observations in the problem. This is equals to 174. So we are going to write it as 174 by here the number of observations as a 6, and we are going to finding out the value of y bar is 29. So now 27 minus 29, so this is minus 2. Minus 2 whole square is a value of 4. Next 30 minus 29 is 1. 1 square is 1. 28 minus 29 minus 1 square is 1. 31 minus 29 is 2. 2 square is 4. 22 minus 29 is minus 7 square is 49. 36 minus 29 is 7. 7 square is 49. Now the thing is, we are going to finding out summation of yi minus y bar whole square is a value of 108. So now the thing, so as per our last, we already noted down the 4 steps of the procedure of test statistic. We need to finding out the value of f is s1 square by s2 square. So now we are going to finding out the first value of s1 square. The value of s1 square is equals to 1 by n1 minus 1 into summation of xi minus x bar whole square. So here, as the number of observations is 5 minus 1, so we are going to finding out 1 by 4 into summation xi minus x bar whole square. This is a value of 24.6. We are going to finding out the value of s1 square is 5.3. In the same way, we are going to finding out the value of s2 square is 1 by n2 minus 1 into summation of yi minus y bar whole square. Here the number of observations is 6, n2 is 6 observations, so we are going to finding out 6 minus 5 is 5. We are going to finding out 108. So the value of s2 square here as 21.6. We are going to finding out here s2 square is a bigger value. So we are going to write the test statistic of f is equals to s2 square by s1 square only. That is what, 21.6 by 5.3. This is the calculated value of f, because here the numerator is a greater value than the denominator. So here also we are going to finding out the degrees of freedom n2 minus 1 comma n1 minus 1 degrees of freedom. So here the calculated value of f here is 4.075. 4.075. Because here this numerator is a greater value. This numerator you are going to write in the calculated value of f numerator, and the lesser value you are going to write in the denominator. So the calculated value of f is 4.075. Now we are going to compare this with the table value. The table value of what we are going to compare, n2 minus 1. It means that we are going to finding out with the table value of 5, 4 table value. We are going to finding out the table value of f of 5, 4. Now let us see the table value. We are going to finding out the table value of 5, 4. So 5 is a greater variance. The greater variance, as we already discussed in the last problem, as the upper part 5, 4. This is a value of 6.26 is our table value. 5 is the upper part of the tabular form and 4 is on the right hand side. So 5, 4, the table value here is 6.26. So now we are going to conclude the value of here. So as per this table value, we have the table is 6.26. As per our the last discussion, we are going to define the table is 6.26. Now the calculated is 4.07 and table value here is 6.26. So the calculated f is less than the tabulated f. So we are going to finding out our accepting h naught. So accepting h naught means we are going to conclude that there is no significant difference in the two population variances, or our given problem is they are asking to finding about that to finding out these two populations have the same variance. This is what we are going to accept, and this is what we are going to finding out accepting H naught. The two samples, it has been drawn from the same normal population. In this way, we are going to conclude F test for population of two variances. Thank you.